Why are there vast glowing clouds of gas and dust between the stars? These objects, known as nebulae, are not just empty space. They are immense interstellar structures that play a crucial part in the cosmic cycle of matter. From these clouds, new stars are formed, and into them, the material of old stars is returned. A common type of nebula is the Emission nebula. These are clouds of gas, primarily hydrogen, that are being energized by the intense radiation from nearby hot young stars. This energy ionizes the gas, causing it to glow, often with a distinct reddish hue. These glowing clouds are regions of active and ongoing star formation, where dense clumps of gas and dust are collapsing under gravity to form the next generation of stars. In other instances, a cloud of dust may be positioned near a star that is not hot enough to ionize the gas. In this case, a reflection nebula is formed. The dust grains within the cloud scatter the starlight, much like how fog scatters the light from a car's headlights. Because blue light scatters more efficiently than red light, these nebulae typically have a characteristic blue color. They are not producing their own light, but are reflecting the light of their stellar neighbors. Some cosmic clouds are visible not by the light they emit or reflect, but by the light they obscure. These are known as dark nebulae. They are such dense concentrations of interstellar dust that they block the light from stars or bright nebulae located behind them. They appear as dark, empty-looking patches against the bright backdrop of the Milky Way. But these dark regions are not empty. They are very cold and dense regions within the galaxy, and they contain the raw material from which future stars will be formed. Nebulae are also associated with the final stages of a star's evolution. When a star similar to the Sun exhausts the fuel in its core, it sheds its outer layers of gas into space. This expanding shell of ionized gas is illuminated by the hot, leftover core of the star, creating a planetary nebula. These objects are often symmetrical and display intricate structures, and they are a way that stars return processed material back into the interstellar medium. A more massive star ends its evolution in a far more violent event, a supernova explosion. The material blasted out from this explosion crashes into the surrounding interstellar medium, creating a supernova remnant. This expanding, chaotic cloud of debris is heated and energized by the shockwave of the explosion. Supernova remnants are a primary source of heavy elements in the universe, seeding the galaxy with the material needed for rocky planets and other complex structures. These processes form a continuous cycle. The material dispersed from planetary nebulae and supernova remnants enriches the interstellar medium with heavy elements. Over millions of years, this material cools and gathers into new, dense, dark clouds. Within these dark clouds, gravity can once again take hold, collapsing the gas and dust into new clusters of stars, which then illuminate their parent clouds as emission or reflection nebulae, beginning the cycle anew. The great clouds of the cosmos are the beginning and the end of the stellar process. They are the raw material for new stars and the receptacles for the material of old ones. From the red glow of a star-forming region to the expanding shell of a supernova remnant, nebulae reveal a dynamic and cyclical process of creation and dispersal that continuously reshapes the galaxy.